Welcome, everyone. It's a pleasure to have you with us today for this webinar hosted by Filtralite in collaboration with Smart Water Magazine. My name is Cristina Novo, and I am technical editor at Smart Water Magazine. We're here to discuss a topic that's both timely and essential: how to increase profitability in water treatment plants using an advanced filtration solution, Filtralite. In today's industry landscape, water professionals are continually navigating the pressure to do more with less, increase water output, improve water quality, reduce operational costs, and meet growing sustainability targets, all without major infrastructure changes. Filtralite offers an answer to these challenges. Made from expanded clay, Filtralite is a highly porous filter media that stands out for its capacity to retain suspended solids more effectively than traditional materials like sand and anthracite. It enables longer filtration runs, significantly fewer backwash cycles, and reduced energy and water consumption, benefits that translate directly into increased plant performance and cost savings. The implementation is simple too. Filtralite can be used to directly replace existing media without any need for structural modifications. What's particularly compelling is that these are not just theoretical advantages. With more than 500 installations in over 50 countries, Filtralite has already proven its value on the ground, from drinking water facilities to wastewater treatment and to pre-treatment for desalination. The results have been consistent: higher efficiency, lower operational expenses, and in many cases, a return on investment in under 3 years. We are fortunate to have with us Truls, International Sales Manager at Filtralite, who will lead us through this discussion, with examples that highlight the versatility and economic advantage of switching to Filtralite. Today, we're going to explore how this solution works and how it can be tailored to meet the specific needs of each facility. Before we dive into today's topic, a few quick notes to ensure that you make the most out of this session. First, by attending this webinar, you are eligible to earn a continuing professional development credit. To obtain a certificate of attendance, please scan the QR code that you will see displayed on the screen and follow the steps. If you would like to access translation, you can select your preferred language for subtitles using the options at the bottom of your Zoom screen. We're going to finish today's webinar with a Q&A session, so please feel free to submit your questions as we go. This is a great opportunity to dig deeper into the technical details or explore how Filtralite might apply to your specific situation. Our speaker will address them during the dedicated Q&A session at the end of the webinar. And please don't forget to include your name and your organization with your questions. We're looking forward to a dynamic and engaging discussion. And now let me introduce you to today's speaker, Truls, International Sales Manager for the Nordics, UK, and Asia at Filtralite. Truls brings over 14 years of experience at Saint-Gobain and Leica, where he has led strategic projects focused on construction and filtration materials. Throughout his career, he has combined technical know-how with a focus on business development and long-term value for clients. His background also includes experience in production, client-focused sales, and broader industrial markets, giving him a well-rounded perspective on how to deliver effective, results-driven solutions. His expertise is grounded in real-world implementation, and he's here to share valuable lessons and case studies that show how Filtralite can help you maximize the efficiency and sustainability of your plant. Welcome, Truls, and the floor is yours.
Thank you very much, Cristina, for a very sweet and nice introduction. I will share my screen. Today's presentation will be focusing on how we can improve the profit of a plant or plants. Just a short background, who is Filtralite? Filtralite is part of Leka International, and Leka International is owned by Saint-Gobain, which is noted on the stock exchange in Paris, where we also have our headquarters. PAM is also working in the water business, and probably a few of you have heard about them. We also have some cooperation internally between Filtralite and PAM. I'm quite sure that a lot of you have heard about Saint-Gobain, but I also hope that you also heard about Filtralite in the past. Filtralite have four different kind of application where we focus on. But the main focus for us in Filtralite is drinking water plant and wastewater treatment plant. But we also have product for air treatment and also some special product for phosphorus removal. The main focus today will be on drinking water and wastewater treatment plants. I just want to show you very quickly how Filtralite is manufactured. We have some clay that we take into a huge rotating kiln. In that kiln, we have very high temperature, like 1150 degrees. At that temperature, all the organic material will burn and a lot of gases are released. When these gases are released, you get an expansion. You can imagine this like a popcorn. When you put popcorn in, but when we make popcorn, it's more uncontrolled expansion. But when we produce Filtralite, it's more or less the same principle that happen, but we can control the expansion with the temperature. And that makes us make different densities. So we have three different density. We have high density, we have medium density, and low density. And since we can control the density in our production plant, it makes us also to make combination of product together. So we can always use normal density, what we call low density, which we call normal density, together with high density, to build a dual media filter with a lower density in the bottom and a higher density on the top. Okay, so when the material coming out from the kiln, then we cool it down, and then we go to our sieving lines. First, we take out the raw material and watch it on over and under the grain size, go down back and be crushed and goes down to the sieving line. Then we sieve the material, put it in big bags, and then we transport it to the client. So this is a brief overview of how we produce Filtralite. Okay, let's go a little bit deeper into what is Filtralite. As Christina said in the introduction, I've been working on in the 15 years with Filtralite. I've only been working with that all these 15 years. And one of the reasons for that is that it's an amazing material. I will come with a statement that say that it's probably the best filter material in the world. And it's very simple. What you do when you want to do a test with Filtralite, you take just out the sand or sand anthracite or whatever filter media you have, and you just replace it with Filtralite. You don't do anything else. No other modification is needed. Just take out the old material, replace it with Filtralite, and then you run as normal. So only one thing which is important to keep in mind is that you need to reduce the speed of the backwash pump or the frequency of the backwash pump. Because Filtralite is a much lighter material compared to sand, so to avoid that you flush the material away, you have to reduce the frequency of the backwash pump, which will also give you benefit in saving on the energy consumption. As you can see from this picture, you see the structure of Filtralite. It's a high porosity. And as I will see later on in the presentation, this explains all the benefit that you will get with Filtralite. All the benefit you will get with Filtralite can be explained how the material look like. One thing is the porosity, which is very important for biological filtration, for bacteria and this kind of application. But it's also the size of each of the grains are different and packed in a completely different way than sand, which we'll talk more about later on. So if you make a comparison about sand and Filtralite, the reason to make a comparison with sand and Filtralite is because sand is the most used filter material worldwide. So if you look how sand look like, it looks more like a round particle. And the only way that the turbidity or a suspended solid coming into the filter can be catched is between two sand particles. So, and if you compare with Filtralite on the right side, you see that Filtralite is a high porosity, and you can also see the sizes of how the grains look like. All of them are different. So they are packed in a complete different way than sand are packed, which means that you can store much more suspended solid between the Filtralite particles, but also in the pores. So if you have 1 cubic meter available, then you can store much more suspended solid in 1 cubic meter with Filtralite compared to 1 cubic meter with sand, due to the properties of Filtralite. So keep this in mind when we now go further on how Filtralite look like, because as I said, that explain all the benefits. And that is what we will show case studies later on, and how you then can increase the profit in your plant. There are different ways that you can increase the profit by using Filtralite. First of all, you can increase the production, because if you have Filtralite installed in a filter, you can have higher filtration speed through the filter. That is one way to increase the profit. Another way is to reduce the operating cost by run the filter longer before you need to stop and backwash. I will come more back to this later on in the presentation when I show you the case study, because you have some different kind of different case studies that I will show later on. Filtralite is also a long-term solution for water filtering. It means that they are very high lifetime. One of our first application was with a wastewater treatment plant that was built in Oslo by Degremo, which now is a part of Suez, they have been operating since 1994 with the same filter media without changing that. They needed to do refurbishment of the concrete because the filter media was tearing on the concrete wall, so they need to do refurbishment on the filtration cells, but they still use the same filter material they installed 30 years ago. And Filtralite is easy and a very fast solution to improve the performance and increase the profit of a plant. We can break this down, as I mentioned, into 3 different parts. We can focus on the production. Some plants are limited by the production. And one way to get more water out of the plant is to change the Filtralite so you can increase the filtration rate and then be able to produce more water. Some plants, we have a case study of that as well, they have enough capacity, but they still change to Filtralite to reduce the operating cost. And the third one is reduced footprint. Because if there is a new plant to be built, in the design stage, you can design, instead of, for example, having 10 filtration cells, you can go down maybe to 5, but at least 6 with the same condition and achieve the same output, the same production with a smaller footprint. So if you focus on the production, we know that there's a study that has been done by Thames Water that show that if you use single media sand and compare with single media of Filtralite, you can run the filter 5 times longer. That means instead of backwashing the sand filter once a day, you can backwash the Filtralite filter every 5 days. If you do the comparison with single media sand, I know that is an unfair comparison with single media compared to dual media, what we call Filtralite monomulti. Filtralite monomulti is a dual media filter where we have high density filter material in the bottom and a lighter material on top. Then we can, instead of backwashing once a day, we can backwash every 8 days. We have also seen that you can increase the flow rate. Very often you can double the flow rate or more. The kind of limitation here when you increase the flow rate is the water quality. Because all of us know that I'm working in the water business is that you know when you're higher speed is a higher possibility that the suspended solid will go through the filter. So if you are on the limit with the water quality today, then maybe the solution is not to increase the flow rate. But if you are far below the targets, then that could be a good option. As mentioned before, Filtralite, because of it, how the filter particle are packed together, and because how each of the filter particle look like, you can store much more suspended solid compared. And that means also, if the all conditions are same, you have the same grain size, you have the same depth, then you will get better water quality if you measure that in STI or turbidity. So if you have a filter with exactly same condition, but you have one with sand or sand anthracite and the other with Filtralite, you will get better water quality. And as I said, because of how Filtralite look like with a high porosity, it's a perfect material for the bacteria. We like to say that Filtralite is a 5-star hotel for the bacteria. And because of that, we can reduce, for example, ammonia, iron, manganese. We have many applications for ammonia removal. We have seen that we are more than 95%. We have some data which has shown that we can remove up to 97.5%. We did our own analysis, the client did their own analysis, and we made a comparison, and the average was 97.5. And iron, we can increase that, and we can reduce that very down to a non-detectable level. So if you are around 2-3 ppm of iron, you can come down to 0.001 or nearly close to zero with the right condition. That goes quite fast to build up the right bacteria for iron removal. The temperature is the higher temperature, the faster it will go. And the same for manganese. Manganese is a little bit more tricky and harder, so you need longer time to build up this right bacteria for that. But you are able to come down to 0.01, 0.02 ppm for manganese as well. So Filtralite is used for both physical filtration and also biological filtration. If you look at the operation and reduce the cost at the plant, as I said, because of how the unique properties of Filtralite, that means that you can reduce the need for the backwash. So less backwash will give a saving in backwash water, and that water, when you use less water for backwashing, that means you have more water available to sell to the client or out to the municipality. And less backwash also means less use of energy. So if you take these two together, the saving in water and energy, you always have a payback time, always less than 3 years. We have seen that the client have payback time down to 1 year and sometimes as low as 6 months, because they have some problem and they are using sand, and very often you see in the sand filter clogging in the upper part, and they need to backwash maybe 2, 3, 4 times a day. And for sure, all the time when you do the backwash, you lose production. Water you could potentially sell. Another interesting thing which is important to keep in mind is that because Filtralite is a much lighter material, so it's much easier to backwash Filtralite compared to sand. We always recommend in the backwash to use a combination of water and air, because that gives the most efficient backwash. So as I said before, depend on which kind of Filtralite solution you compare. If you compare single layer sand with single layer Filtralite, it can be up to 500%. That means instead of backwash once a day, you backwash every 5th day. And if you take 2 media of Filtralite compared with sand, then it's not every day, but every 8 days. And also the lifetime of the product is very important. And then the last one, which is footprint. This is especially important when when you plan to, for example, to build a new plant or increase the capacity of the existing plant. Because we know with Filtralite, it's a study done by Suez that says that you can reduce the number of filters by 30 to 50%. So instead of having 10, you can go down to maybe to 5, but to be a little bit conservative, maybe 5, 6, 7, something like that, 6, 7. But still, it's a dramatic reduction in the footprint. I will now show you some references that we have delivered in past. A few of them are quite old. Some of them are a little bit more new. Another important thing as well is that Filtralite is NSF approved. And we also have this European Drinking Water Certificate. And we also have some other certificate from specific for certain countries. I mentioned earlier, Thames Water, they had really big problems. Thames Water is 13, I think it's 13 or 14 different plants around London. And all of these plants in the past used to be with sand or a combination of sand and anthracite. I will not say a couple of years ago, but many years ago, it's now maybe at least 15 years ago, they started to get big problem in the production plant because of the algae. The algae in the raw water has increased dramatically, which means that the production capacity went down. So Thames Water started a big research project in the R&D center, which Michael Chips was in charge of that project. And they need to find a solution because the bottleneck in the production was the filtration because of the increased amount of algae in the incoming raw water. So what they did a screening of all commercial available filter material in the world. They have been to Kempton Park, to the research center for Thames Water. I've seen all the samples, all of the things, what they have done there. And they ended up with a kind of first a big screening where they picked up some material. For sure, they need to test in a very impressive pilot plant they have there. Sand, because they had sand in most of the filters in the plants, and also combination of sand and anthracite. Filtralite, 2 layers of Filtralite, was one of the four different options, and the last was recycled glass. The reason that recycled glass was the fourth was because they had a local source in London. It was environmental friendly and easy available. But out of these 4 different setups, Filtralite showed much better performance than all the other. So by changing from sand or sand anthracite to Filtralite, they increased the production so much so they didn't need to do an extension of the existing plants. Some of the filter, they increased the filtration rate, doubled it from 5 to 10, and got them a saving with 10,000 pounds per filter. Keep in mind now, 10,000 pounds per filter. That was only based on the saving in energy and the filtered water, because less backwash water used, less treatment of the backwash needed. So just the saving in energy and treatment of the backwash water saved them £10,000 per filter per year. And I discussed, okay, since you increase the filtration rate from 5 to 10, then you have much more water to sell now. Michael Chips told me that but we cannot take that into account because then the filter material is actually paid before we have done the installation. So it doesn't make sense to make that calculation, because our alternative was to do an extension of the existing plant. So this is a good example for a kind of things that happen with the raw water, and the way the easy kind of a quick fix solution. Just take out sand, replace it with Filtralite. But they did a much bigger work out of it. I think this, from the start until the end of that project, with screening all the different filter media, they spent around 3 years on that project. Here is another project from Palmachim. They have a salinity of the water around 39,000 ppm, or 39,000 milligram per liter in the salinity. And the challenge was that they needed more water, so they need to increase the production by 50%. So what they did, they took out the filter media they had and replaced it with Filtralite NC 1.5, 2.5. By doing that, they could increase the filtration rate from 7 to 12 meter without doing any kind of modification. And that is quite impressive when you go from 7 to 12. At the same time, they had also increased the time between the backwash from 30 hours to 200 hours. So you have much more suspended solid coming in because you increase the filtration rate, but still you also increase the runtime between the backwashers. On top of that, they also saw that they got some benefit further up in the process. For sure, they got less biofolding in the RO plant, which gave them less cleaning of the membrane. Less cleaning of the membrane increased the lifetime of the membrane, which also had a which was very important for them. On top of that, they could also reduce the cartridge filter. They used to have 20 micron, and they changed every month. 20 micron cartridge filter changed every... No, it was not changed every month, every second month. Every second month. So 6 times a year, they changed this 20 micron cartridge filter. Then they changed to 5 micron, and very logical. Then you should think that you should change more often because you go down from 20 micron to 5. They changed twice a year. Just that saving on the cartridge filters gave them a saving per year of 300,000 euro per year. So this is a case where you had problem with the filtration. You need your bottleneck was the filtration, but you also got some upflow benefit. Less biofolding in membrane, and also the saving on the cartridge filter. This is a case from Bedrikov in Czech Republic. This plant, we had a cooperation with Envipure, and we still have a cooperation with Envipure in that region. Envipure have a technical advisor that is Professor Peter Dolec. He works as a technical advisor for Envipure. He came over this material, and he knows very well this plant, Bedrikov, and introduced Filtralite to them. But they said that we don't need higher production. We have 8 filters, and we have enough capacity. We can run faster, and we have enough. But still, they changed to Filtralite because to reduce the operating cost. So what they did was that they, instead of have 8 filters in operation, they could reduce to 6 filters in this case. That gave them flexibility in a way that when they have 2 filters out of operation, they could do maintenance, change nozzles, and just have them ready to start up if needed. For sure, it was a little bit higher demand of water in the summertime, but still 6 filters was enough for them. So they reduced the backwash and had a 75% saving in the energy. And the return on investment was less than 3 years. I think it was a little bit more than 2 years in this case. And then this is a plant very close to where I'm living. This case is quite old, but they had big problem with clogging of the sand and anthracite filter. They have something we call mud balls as well, which can happen due to the chemical dosing and the particle in the raw water. This case, they changed. They kept the sand in the bottom, but they took out anthracite and replaced it with Filtralite. So they had a saving of 125,000 cubic meter each year, and return of investment was less than 3 years. So, as you probably understand from this presentation, why you should choose Filtralite. For sure, if you will need to improve the water quality, reduce the operating cost, or you need higher production, Filtralite is a quick fix that can help you to achieve that and then increase the profit in your plan. As I said, we have many applications worldwide, and this is just a few of the companies that we have delivered to the last couple of years. Some of them from France, some from Norway, Samsung from Korea, Spanish company like Acciona, Atal Engineering from China, Kelda Water Service from Scotland, United Utilities, a little bit all over, Thames Water, and Veas in the top left corner is the kind of the first and very important reference for us when it comes to wastewater treatment plant, because they have been operating in Filtralite, as I said, for more than 30 years with the same filter media. So, okay, Filtralite, more water for less cost. So thank you very much for your attention. So I really hope you have some question. Feel free to ask, and I will do my best to answer them. So thank you very much.
Thank you. Thank you, Truls Kleefstad, International Sales Manager at Filtralite, for your presentation, taking us through the practical, technical, and economic benefits of Filtralite in water treatment. We've seen how it can increase water production using existing infrastructure, reduce the backwashing needs, and ensure a smaller footprint in both new and in existing plants compared to conventional solutions like sand. Truls has shared with us case studies from implementation in different countries that show improvements in filtration rates and operational savings with a return on investment of less than 3 years. Now we would like to hear from you, the audience. So we're going to open the floor for the Q&A session. So if you have any questions about what you've heard today, or you want to know a little bit more about how Filtralite could work in your specific context, this is your chance to engage directly with our speaker. Let's get started. Okay, so feel free to send your questions using the Q&A module at the bottom of your Zoom screen. Our expert is here to provide insights and address your inquiries. And please don't forget to include your name and your organization with your question. And as a quick reminder, attending today's session makes you eligible for a CPD credit, and you will be able to receive a certificate of attendance by scanning the QR code that will show up on the screen. So we already started receiving questions, and we're going to start with them right away. The first one is from Pavel Dobias, a technologist at MBPUR in the Czech Republic. And it's about the Palmachim desalination plant case study in Israel that Truls presented. And the question is, what type of filtration sand was used as the lower layer?
This case is a little bit special because they have been very locked about the information, but the person that was in charge of this project, I met him in a conference in Israel many years ago, and he had then left and was in he left his position, and he went in a position in the government, and that is the where I have the information because I have, and he didn't specify the sand. What was important for us in this case, we didn't want to focus on other thing than Filtralite and what the benefit. So he shared very kindly with us that information, but he didn't want to go more into detail what kind of sand they was using. But this is, it's not so many option for sure, because since we supplied to them twice, because the first project we did with them was in a gravity filter, and what they did there was that on the top of the gravity filter, a few years later, they put it a pressure filter, and they ordered more Filtralite. So based on the Filtralite we delivered, which was Filtralite NC 1.5, 2.5, it's kind of high possibility they have sand around 0.8, 1.2. It can theoretically be down to 0.4, 0.8, but I don't know exactly. I probably asked that question, but it can be that he didn't remember or whatever, but I don't have that information. But there are two options, 0.4, 0.8 something, 0.8, 1.2, something like that.
Okay, thank you, Truls, for trying to answer that question as best as possible. We'll move on to the next one. This one is from Borja Ojembarrena, process engineer at Verdalia Bioenergy in Spain. And he says, I'm exploring solutions for liquid digested treatment. And the question is, could clay-based membranes operate with total suspended solid levels above 50 grams per liter, so more than 5%? And there's some follow-up questions, but I'll let you answer that first.
Yeah, well, I think I need to repeat it because you said clay-based membrane.
Yes, he says membranes, but my guess he means your clay-based product.
Yeah.
With total suspended solid levels above 50 grams per liter.
Yes, that can do, because this is all about what we normally do is that we have a one-page Excel spreadsheet where we just ask some basic information when you fill in that. Based on that, we can give a recommendation. But Filtralite, for example, when you have you can have much higher level on the COD, BOD, all of these kind of things, which is a few hundred, and then we are able to reduce that dramatically. But everything about that is for sure is always a balance, because the bigger grain size you go for, the higher turbidity or suspended solid you can take. Because it's always a balance. If you go down in the grain size, then for sure the water quality out will be better, but you need to backwash more frequently. So it's always a balance between how often you need, we'd like to do the backwash. That will be depending on what kind of recommendation we will give. So everything comes to the grain size. The bigger grain size, the longer you can drive and the longer you can run the filter, and the higher suspended solid you can remove. Because the bigger it is, the more space it will be also available. And this is also it's very complicated, because you also have the chemicals up front, how you dose the chemicals, all of these things, but always a balance about different things. But 50 ppm, no problem.
Okay, thank you, Truls. There's a follow-up question to that, and it's what level of ammonia removal could be expected at concentrations around 3-4 grams per liter of suspended solids?
Yeah, so if you have 3-4 ppm of ammonia, that is absolutely no problem. So we say that at least, because this is very depending on, for sure, temperature is important. It's especially very important in the startup to get the right bacteria and the balance, the right phosphorus for the bacteria to do the job properly. And but I will say that we say that, as I showed also, at least more than 90%, but we have some cases from a couple of years ago when we had with Delhi Yalbord in India. Delhi Yalbord did their own analysis. We did our own, and we made a comparison, and then we had showed that we had removed 97.5% of the incoming ammonium. I don't remember exactly but I think it was something around 3 to 4, as you said, 3 to 4 ppm or milligram per liter. So, but at least as a minimum 90%, but we have seen that it can be higher.
Okay, thank you, Truls. So we go on to the next question. This one is from Gunther Lempert, engineer at Aquarius Consult in Namibia. And the question is, can Filtralite also be used for nitrate removal, for example, in fixed bed denitrification systems?
Yes, that is that can be used. So I think if you go to filtralite.com, you can find some more specific case study about that on filtralite.com.
Perfect. Thank you, Truls. So yes, further information on the Filtralite website. Another question from Fernando Sanchez, project manager at TIPSA in Spain. And this time is about iron removal. So for iron removal using Filtralite, does the iron need to be in the ferric ion form, or can it also be removed as the ferrous iron form?
Yeah, we very often, there are some, not very often, it's some oxygen in the water. So then you get this Fe2O3, which is bigger and easier to pick up. But we have also seen that sometimes when you have lack of oxygen in the water, we still come nearly down to non-detectable level with iron. we should maybe done a PhD to really understand what's going on when we have this kind of biological filtration, but it just works. Especially, as I said during the presentation, iron is quite easy to remove. This bacteria develop quite fast, but you all know that if you take clean water and put some iron, some iron in, iron chloride, and that is dissolved in this water, for sure it will go straight through the filter. But still, with all other things, the mix, the kind of a cocktail that coming in with dissolved iron into the filter, there are something that happening, and we see out, because as I said, that it takes maybe 3-4 weeks, and then you have, because when you start a pilot with the iron, you see that it goes slowly down. Suddenly you are on zero for iron. Exactly what's going on, I cannot explain that, but iron is the easiest to remove with Filtralite, and as I said, that if you take iron chlorine dissolved in clean water, that the iron is too small to be catched up in the filter, but there are still something that happening when you got this right bacteria, the biofilm, and also the other things, the kind of the raw water coming in, then it just works, simple as that. So I strongly recommend you, if you have problem with iron, so we can ship some filter media for you, and you do a pilot based on the water you have and the condition you have, and then you will see that the filter media, the Filtralite is simple, it just works. But exactly what's happening is difficult to know, and I have no clue.
Thank you, Truls. That was a complicated one. So doing a pilot, it's like excellent advice.
Yeah.
Okay, so we're going to move on to another question. This is from Carlos Tagliero, a sanitation engineer at the Ministry of Infrastructure in Argentina. And the question is about the effectiveness of Filtralite for arsenic removal in water treatment applications.
Yeah, it's a good question that I got many times. And Filtralite, I will not recommend Filtralite for if that is also not so easy, straightforward answer. But there are something with arsenic that the Filtralite itself cannot do that, but we have some other, as I said in the introduction, we have some other special product for example, phosphorus removal, and we have a product which is called Filtralite HMR, which is more like activated carbon. So this is a typical case for this kind of Filtralite products. We didn't talk about that at all today, but we have some brochure and these things I can send to you. So in this case, when you have arsenic, then you have two cases. You have activated carbon, or you have Filtralite HMR that you can use. So and I can also connect you with my colleague at R&D, which have been working a lot with this product, this HMR. He's kind of a specialist on that specific product and what we are able to do. But Filtralite that is traditional used for drinking water plants, I will not recommend that for that case.
Thank you, Truls. You've mentioned activated carbon, and we have a question about comparison with activated carbon. This is from Alba Rodriguez from the University of Copenhagen, and she was wondering if you have compared Filtralite with granular activated carbon, and considering that it is also porous and supports biofilm development. And so the question is, how does Filtralite perform in comparison to granular activated carbon in terms of head loss, maintenance frequency, biofilm behavior, and cost effectiveness?
This is a great question. Thank you very much. I like that. We had our plant in Norway, on the west coast of Norway. As I said, I started at Filtralite now soon 15 years ago. And one of the projects that started at the time was with the project on there was an existing plant where they wanted to do an extension to shut down a lot of other small plants to build one big plant that cover all area. They had a very impressive pilot plant with 10 columns that they could operate at the same time, and they tested a lot of different combinations, and activated carbon was one of them. And this case was for a biological filtration. So Filtralite could not even compete in the beginning compared to activated carbon, because you know that activated carbon have some active sites and have a chemical interaction which lasts for a certain time, and then when all of the sites, then you need to take it out and regenerate it. So, but they didn't want that solution because they wanted to use Filtralite or the other media as a carrier for the biofilm. So this benefit was just in the beginning, but when they came and I built up the biofilm, all of these active sites on the activated carbon was used, then we saw the performance went dramatically down, and the performance of Filtralite was much, much better. Their case was that they should never regenerate the material anyway, because they was just looking for a carrier of the biofilm. So that in these cases, you don't need to take out the activated carbon and regenerate it. So, but as I said in the beginning, activated carbon outperformed Filtralite, but in the long term, Filtralite was a much better solution, and also better solution based on, because I was running this pilot for, I think, 5-6 years, and I also saw that because activated carbon is a much softer material than Filtralite, so also the grain size went down a little bit like anthracite. So also the performance for the turbidity removal also went down, because the grain size also slowly went down. So yes, I have some information. It's unfortunately only in Norwegian, but you can use Google Translate, and I can share that with you, this information. So drop me an email, and I can share more specific information about that project. This is a project was for us quite important because first of all it's in Norway. Norway is important for us because of the kind of home market and these things. But we was awarded that project and was finished delivered that project 4 or 5 years ago, and they are super happy, and the plant performing very well. So this is a very good example of biological filtration with Filtralite as well.
Thank you, Truls, for that example with biological filtration. Alba Rodriguez also had another question. It was whether Filtralite had been tested for the removal of organic micropollutants, and if so, if you would have any performance data on that.
Organic. Yeah, there can be organic, can be a lot. I would say it. I'm not 100% sure I understand that question correctly, but if you say it in that way, if you cannot remove it with sand or if you can remove it with sand or sand anthracite, then for sure we can also remove it with Filtralite. But it depends on if you have if this organic material has some active sites, and depending on what it is, so very often the solution for that is activated carbon. But very often we also seen that the client prefer to have Filtralite first, and then they're using activated carbon for very specific thing, substances that you like to remove. So because activated carbon need to be regenerated, you don't want to push that material too much, you want to last it as long as possible because of the cost of regenerating it. So then they very often set in a Filtralite as call it a pre-treatment first, and then they have as a kind of polishing final step with activated carbon. So yeah, you please contact me. We can probably discuss it more in detail, and I can also involve my colleague Guy Norden at R&D. I think that he has much more experience on that specific topic than I have. So, but based on the information that based on the question, I think maybe that could be kind of a solution. Yeah.
Thank you, Truls. So yes, please, we encourage Alba Rodriguez and anybody in our audience that wants to contact Truls also directly for any questions for their specific situation. And but we're going to keep on moving because we still have quite a few questions to get through. This one is also dealing with activated carbon comparison, and it's from Leonardo Ordenat, Works Director at the Intendencia de Montevideo in Uruguay. And the question is if Filtralite could be used instead of sand to reduce the need for activated carbon in removing algae from raw water.
To remove
algae from raw water.
Yeah, that is the case that they showed the Thames water. They had huge problem, and then the problem was bigger and bigger year by year. And then suddenly they come that there was could not deliver enough water. Especially the case with the Thames water is exactly when you in London where you have most of the tourists. It's during like April until autumn, and at that time in the summertime there, then they also had most demand for water. And then also for sure is the time when they have most problem with the algae. So Filtralite is perfect for removing the algae. And as I said, that because of the properties of sand is the most used filter material in the world. Yes, it works, but it's very inefficient. And that is due to how the sand particles look like. They are round. The only way you can trap the suspended solid is between two sand particles. And very often, if you have a depth of, for example, 1 meter, you are not able to use the full depth of 1 meter because with sand, because of how sand particles look like, you're using just the upper part of the filter, and then you need to stop and backwash. So that is the kind of the disadvantage using sand compared to Filtralite, and especially with the algae. We probably have some peaks during the year, then Filtralite is absolutely a perfect solution for to solve that kind of problems. And I also have a report from Thames Water that I'm allowed to share with you as well, and also the presentation they gave I was actually in Spain in Los Palmos in a conference many years ago.
Thank you, Truls. So now we're going to another question, which is quite detailed. This time it's on about durability of the filter media as well as installation and maintenance. It's from Brett Hamley from AWI in Canada. So I'll go with the first question, and there's a few follow-up ones. Do you have any data on media attrition over time?
Yes, this is something you actually can simulate in the lab scale as well. If you have a column, put the media in, and you just let it recirculate. I think there's a standard test how they do that. If I remember correctly, you have non-stop backwash for 200 hours or something like that, and then you take out the material, make a new sieve curve, and then you compare brand new material with material up in the backwash for 200 hours. This is the kind of the way you compare, and you have some other tests you can do also. But what we see, absolutely the best reference we have, as I mentioned before, This is with a wastewater treatment plant in Oslo. And we all know that the backwash of wastewater treatment is much more rougher, much more harder compared to backwash in the drinking water plant. So yes, when the consultant company and the design companies and the things are asking us for a lifetime, we say that okay, you can use 25 or more, because that we are very confident with saying 25 years or more. But we know that this specific reference, and that was the first big one, has now been in operation for 31 years, since 1994. And as I said also, they have done a kind of calculation that said that the tearing of the product is less than 1% per year. And that, keep in mind, that is in backwash in a wastewater treatment plant, where it's much rougher as well. So what they do, the total amount of filter media in that plant is 18,000 cubic meter, and they just top up it 100, maybe 200 cubic every year. And the reason for also the top up is not just the tearing of the product, because they know by themselves that they from time to time have some problem. We know that plant very well because we use this as a reference. We have brought clients worldwide to that plant. And let's say that when the backwash, they have sometimes some problem, maybe some, I don't know, they don't know either exactly what happened, but they see that they blow the material away and they find it in the outlet. So that is also part of it. So, but at least for sure, less than 1%. That is 100%. Yeah.
Thank you for those details. Truls, there's a second question is, does the media degrade due to air scour?
The Filtralite is completely inert material. So if you put it in acid or whatever kind of chemicals you put it in, it will not dissolve, or nothing will happen with the material. The thing is that some problem it can be if you use chloride dioxide or something, some strong oxidizer, when for one reason and another, that is, we strongly don't recommend to do that. The only reason we don't do it, if depending on what kind of application you have, if you have a pure physical filtration, it's no problem. You can use that for in the filter. But if you have a biological filtration, then we don't recommend that at all, because this oxidizer will penetrate into the pores, and it takes a long time before you have replaced all of it. So for all biological filtration, don't use any oxidizer that can penetrate into the pores of the material. But for sure, it doesn't matter what kind of chemicals you're using, they will never dissolve Filtralite.
Thank you. And a couple of questions about the installation practices and maintenance. Can the media be loaded into a filter using a Venturi ejector? I don't know if I pronounced that right.
Venturi
ejector, could it be?
Ejector. I think that they, if I understand it correctly, there are different ways that they can do installation. We have some companies that we cooperate with also worldwide that do installation. Because sometimes the client asks if we can give them a price blowed into the filter. The best solution then is not to send all of these blow-in trucks, because if you do that, that cost per these trucks is much higher. So it's better to have one truck on site that you fill up the truck, you blow in, fill up the truck, you blow in. But what, if I understand this question correctly, this is a kind of a solution where you have a kind of a tank, and you put the media in, and the water coming, and together with the water flow, you take the material with you. That is very nice way to do it. But you can also blow the material directly. It has some kind of, for sure, some limitation. It's not, but to 50 meters, something like that, is absolutely no problem. But everything is depending on the height, how many curves, if it's like up, down, indoor, left, right, all of this. And it's much better if a straight line as possible and the lowest height as possible. Some plant also install it because some of the plants, which is kind of smaller plants, they have the crane in the roof where they just put the big bag on and then just cut the big bag and the material goes straight into the filter. But if they have very big filter, where the filter is like 200 cubic meter each of the filter, that is very time consuming. So then I can recommend the solution that you mentioned in the question, this ejector. That means that you have the water and media coming together, and you use the water to transport the material in. There is on our website you can find a case from, I think the case is from France, where you see how we take out the material and how we installed a new material. It's a video that you can find there in some of the case studies. So just have a look there, or contact me directly and I can send you the link.
Thank you for clarifying that, Truls. One last question in this set is surface skimming required after installation or periodically afterwards?
Yes, not periodically, but by the installation, we always recommend to do a kind of a skimming, which you do also with all the type of material. I don't say that this is mandatory. This is very depending on how your plant look like, what the freeboard is, how you backwash, if you backwash with water and air, because we all know when we produce the material in our production plant and we go to the bagging, it will always be some dust in it. And then we have some handling. It depends on if it will always go to the truck, and then it maybe go from the truck straight to the client, or it go from the truck to the harbor, then it's unloading at the harbor, stuffing of containing coming to the harbor, another place in the world, and then it's handling out again to the truck and to the plant. All of these kind of things, handling of the material will also generate a little bit more dust, because this is also some unique thing with the product, is that the material is not so strong in itself when it's dry, but something happening when it's coming into the water, the material get much stronger then. So this is a kind of a thing that we always recommend you to do. When you install the material, you do a backwash, and then you see on the surface if you have a kind of a thin layer of dust, then you have two options to remove that. You can do the, as you said, the skimming is one option. The other is to have a kind of a little bit more heavy backwash, and then you will get rid of the dust. But sometimes if you have very high freeboard and you just probably have water, no air, all of these things, then we probably recommend to take a skimming. But this is something very easy to find out by yourself. Do a proper backwash, but keep in mind if you have sand, replace it with Filtralite. You need to reduce the frequency of the backwash. If not, you will lose the material, and you don't want to do that. So that is the only thing to keep in mind, is that you reduce the frequency of the backwash pump. So when you've done a proper backwash, start slowly and rather increase the frequency between each backwash until you see that you get less and less dust. And then because it's very easy to see if you have dust on the top or not when you drain the filter. So there are two options: backwash the dust or do a skimming.
Thank you, Truls, for explaining those options. We're now moving to another person's questions. This time there are two questions from Javier Mascaros from Global Omnium in Spain. And the first one is, can Filtralite be used in vertical rapid pressure filters?
Yes.
Okay.
That's an easy one. But Filtralite is used in open gravity filter. It's all kind of filter. If it's pressure filter, horizontal, vertical, it doesn't matter. They can be used in all types of filter.
Okay, perfect.
Yeah.
So his second question is, what are the recommended filtration and backwashing velocities for Filtralite?
This is nearly impossible to answer, because all the products we have a special instruction and a recommendation for each of the product. So that will also be depending on for sure the water temperature and these things, but we have information from all of the products we have. So when we see that, okay, this is this product that I recommend for you, then I will also support you with the right documentation for that product, and then you can see the backwash curves and these kind of things. So yeah.
Okay, thank you very much, Truls. One more question. We're a little bit over time, but we'll answer a few more. So this one is from Dennis Trostel, and he's from the Pure Life Engineering in Chile. And it's when comparing Filtralite Pure NC 0.8, 1.6 with activated carbon, which one offers a larger surface area?
Yeah, there are different types of this is information we can send you as well, and then you can get do the comparison by yourself. You can ask the supplier of the activated carbon to get the same information, and then you can compare the products. As I said, as I mentioned during the presentation, in a production, when you produce the product, we can control the density of the product by adjusting the temperature in the kiln. So we have like 3 different densities, and for sure we have much more space available in and more open pores with the product with the lowest density. So then you also have more surface area available. So this I can send you for all of these 3 different products. We have NC 0.8, 1.6. We have MC. M is medium density, and C means that the material is crushed, 0.8, 1.6, and HC, high density crushed, 0.8, 1.6. So this I can send all of these 3, and you can compare with the product data sheet from the activated carbon supplier.
Thank you, Truls. So this has been a very interesting discussion. We're gonna take one more question, and it's another question from Brett Hambley from AWI in Canada. And his comment first is, many of the examples reference replacing existing anthracite with a coarser Filtralite material. And the question is, has any testing been done to compare Filtralite with new anthracite of the same size? For example, 1.5 to 2.0 millimeters. And his comment is, I would expect that a coarser material would improve filter capacity, so lower head loss, but without long-term data, the increased capacity might be short-lived. All yours, Truls.
Yeah, now for sure that, as I said, the only we just said was an unfair comparison was the study that the Thames Water did when they compared, and they did it by themselves, single layer sand with dual media Filtralite. That is comparing apple and apple. That is, as I said during the presentation, is an unfair comparison for sure, but we perform far much better. So all the kind of the comparison is done is for sure has to be with the same grain size of Filtralite as the same grain size with anthracite, and for sure also new material for both. So you cannot because we know that anthracite is a much softer material than Filtralite, and we know that when you have an application where you're using sand in combination with anthracite in a filter, when you backwash with a combination problem, air and water, the sand which will polish the anthracite, and over time we've seen the grain size of anthracite goes down, and we see the performance then of the filter for sure will always go down. And that is logical because of how the properties of anthracite is, and it's much softer. That is what's happening. So if I understand as a question, yes, for sure, we need always, when we do this comparison, we need to apple with apple. That means same grain size of anthracite, same grain size for Filtralite. If not, then it's not a fair comparison. So but you can also say that if you have lower grain size of anthracite and bigger of Filtralite, for sure you can store much more suspended solid. But what will happen in this case with bigger grain size? Okay, that will have an influence on the water quality, because then you will probably have better water quality with anthracite. So then there's always this kind of balance you need to keep in mind when that we always do when we give a product recommendation, because you have this questionnaire, very simple, because some clients are always on the limit with the water quality, so they cannot do any compromises with the water quality, for example, and still they want to increase the production, which is nearly impossible, because when you go up in grain size, that will happen something with the water quality. But if you keep the same grain size, but you increase the filtration speed, that will also have an influence on the water quality. So all of these things need to be taken into account in all the different decisions that have been done. But yes, I agree with you. When you make a comparison, you have to compare apple with apple. If not, it doesn't make sense. Yeah.
Thank you, Truls, for this very detailed discussion. We're reaching now the end of the session. So before we wrap up, is there anything else you would like to add to the discussion?
I will thank you for your time, and you are very free to contact me directly if you have some question you didn't want to ask now, or if you have some follow-up question whatsoever. I'm here to support together with the rest of the team to support you, and I will put my colleague in copy that can be in closer contact with you if it's in South America, wherever you are based. So you can also talk directly to them in Spanish or French or whatever language you prefer. So feel free to take contact. We are here to support you.
Thank you. So thank you, Truls. So please contact him directly, Truls Kleefstad, International Sales Manager at Filtralite. This session and this very interesting discussion has underscored the crucial role of high-performance filtration media in driving profitability and efficiency across diverse water treatment contexts, from drinking water but also wastewater and desalination. And we've seen how Filtralite's porosity and proven track record make it a powerful tool for any facility that wants to achieve more water for less cost. And before we close, just a quick reminder, the webinar will be available for on-demand viewing on the website of Smart Water Magazine. Thank you once again for being with us today. And we hope you found the session both informative and inspiring. And we look forward to welcoming you at future webinars. Thank you.